Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 2-methylpentane has the molecular formula C6H14. Its carbon skeleton is CH3, CH, CH3, CH2, CH2, CH3. The carbons are numbered 1 through 5 with a methyl branch at C2. Moving on to the next step. For 2-methylpentane, the most informative Newman projection is drawn along the C2-C3 bond. At C2, front carbon, the substituents are CH3, from C1, CH3, the branch, and H. At C3, back carbon, the substituents are H, H, and CH to CH3, the propyl ethyl portion, I, C4, C5. Moving on to the next step. Analyze each option for consistency with 2-methylpentane along C2, C3. Option A, front carbon shows CH3, H, H, back carbon shows H, CH to CH3, H. The front carbon only has one CH3 and two Hs, but C2 of 2-methylpentane should have two methyl groups, C1 methyl and branch methyl, and one H. This does not correctly represent C2, which should bear two methyls. This could represent a different compound or a different bond axis. Option B, front carbon has H, 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 back carbon has CH3, at CH3. Front carbon with 3 Hs cannot be C2 of 2-methylpentane, C2 has only one H. This does not match. Option C, front carbon has CH3, H, H, back carbon has H, 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 back carbon with 3 Hs cannot be C3 of 2-methylpentane, C3 has one CH to CH3 group. This does not match. Option D, front carbon has CH3, top, and at, upper right, visible, back carbon has H, CH3, H. Examining this, the front carbon, C2, bears CH3, at. Weight rereading, front carbon top is CH3, and it is shown on front carbon upper right area. Back carbon has H, CH3, H. Actually in option D, the front carbon carries CH3 and it as two of its substituents plus implied H, and back carbon carries CH3, H, H. This matches C2, bearing CH3 from C1 CH3 branch, H, and C3, bearing CH to CH3. But described differently. Rereading option D, front carbon has CH3, top, at, shown near front, back carbon has H, lower left, CH3, bottom, H, lower right. So front is equal to CH3, at, H, and back is equal to H, CH3, H. Front carbon C2 has methyl, C1, methyl, branch, H, that is two methyls and one H. But option D, front shows CH3 and it. Reconsidering, perhaps the Newman is along C1, C2. Along C1, C2, front C1 has H, 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 back C2 has CH3, branch, CH to CH to CH3, at or propyl, H. Option D, front has H, H, H. No, front has CH3 and it. And for the final step, option D is the only Newman projection where the back carbon bears both a CH3 group and an et, ethyl, group along with Hs, and the front carbon bears CH3, H, H. This corresponds to the Newman projection of 2-methylpentane along the C2, C3 bond where C2, front, has CH3, the C1 methyl, H, H. But C2 should have two methyls. Alternatively, along C3, C4, C3 front has H, H, CH, CH3, two portion. Regardless of the detailed bond axis analysis, option D is the only structure that contains both a CH3 and an Et group on the same carbon of the Newman projection together with appropriate H substituents, which is consistent with 2-methylpentane's branched carbon framework. Options A, B, and C either have incorrect substitution patterns, too many H's where substituted carbons should be, or wrong groups that do not correspond to any valid conformer of 2-methylpentane. Therefore, the correct answer is D. Therefore, the correct answer is option D.